Good day, everybody. How are you all? Today we are going to talk about section 3.3. So without further ado, I'll share my screen with you. So measures of position. So these are the objectives. First, we will calculate Z-score. Who is taller, a man 73 inches tall or a woman 68 inches tall? The obvious answer is that man is taller. However, men are taller than women on the average. Suppose the question is asked this way. Who is taller relative to the gender? A man 73 inches tall or a woman 68 inches tall? Okay, one way to answer this question is with a Z-score. So let X be the value of from a population with mean mu and standard deviation sigma. Then the Z-score for X is given by what is the difference of X from the population mean, or what is the deviation of the value X from the population mean. Take that deviation, divide by sigma. So basically Z gives you a measure of how many standard deviations above the mean the number X is located. If Z is positive, if Z is negative, then it indicates how many standard deviations below the mean X is located. Okay. So find Z-score. So adult man mean is 69.4. This particular man is 73. Man is 73. So 73 minus 69.4, that is the deviation, divided by 3.1, which is the population standard deviation. So Z-score is 1.16. That means the measure, the particular point, 73 inches, particular man, 73 inches tall, his height is 1.16 standard deviation above the mean for the men. Okay. Do the same calculation for women. The X value is 68, the mean is 63.8, standard deviation is 2.8, and the Z-score for women with a height of 68 is 1.5. That means the Z-score of 60, the X value of 68 is located 1.5 times the standard deviation above the mean. So in a Z-scale, the woman's height is taller, okay, because the Z-score is higher. Finding the value with a given Z-score, sometimes we are given Z-scores and need to find the value that is the X-score. To do this, multiply the standard deviation by Z and add the quantity to the mean. Okay. Data from National Survey estimate the mean total cholesterol level in milligrams per deciliter in the adult population. Mu is 200, standard deviation sigma is 44. What is the cholesterol of a person? Z-score of 1.5. Notice this Z-score is positive. That means the particular value will be above the mean. So first we take the Z-score of 1.5, multiply it by standard deviation 44, and then add that product to the mean. And we get a score of X value of 266. So when we apply the empirical rule, remember for a standard normal curve, at the center where the peak is the highest, on the horizontal axis, Z is equal to 0. And this standard normal curve, mean is 0, standard deviation is 1. So if your Z-score is 1, that means you are 1 standard deviation above the mean. If your Z-score is -1, you're 1 standard deviation below the mean. And according to empirical rule, approximately 68% of the data will have Z-scores between -1 and 1. And similarly, approximately 95% of the data will have Z-score between -2 and 2, and almost all will have Z-scores between -3 and 3. Check your understanding. According to Wall Street Journal, the maximum distance of check-in to the gate at the top US airport has a mean of 0.79 miles. Standard deviation is 0.42 miles. The maximum distance at Tacoma Seattle airport is 0.57. So 0.57 minus the mean is 0.79. It's negative 0.52. Okay. 0.57 minus 0.79. is minus 0.22, and then divide by the standard deviation of 0.42. So the z-score is minus 0.52. What does it mean? That means the Seattle-Tacoma International Airport distance is 0.57 miles, is 0.52 standard deviation below the mean. Why below the mean? Because it is negative. The maximum distance of Hartfield Jackson International Airport is 1.67. So 1.67 minus the mean, which is 0.79. Take that difference and divide it by the standard deviation of 0.42. So it is a z-score of 2.095. That means the distance of 1.67 is 2.095 standard deviation above the mean. And then they said what distance would have a z-score of 1. So take 1, multiply it by the standard deviation, which is 0.42, and add the mean to it, 0.79. That distance will be 1.21. Okay. Compute the quartiles of our data. So like we have 4 quarters in a dollar. First quartile is Q1, 25%. That means 25% of the numbers are below Q1, 75% above it. Second quartile is median, 50% below it and 50% above it. Third quartile is 3/4. So 75% of the data are below it and 25% above it. So we are not going to use this. So let's take a data set. Do I have a data set? No. I'm going through some problems. Let's see. Okay. So we'll have to use this data set. So basically we'll enter the data in L1. Okay, then stat, highlight calc, and then number one word stats, and hit enter. Second line should be empty, then calculate. We'll get the mean, and if you scroll down, first you will get the first you will get the minimum, then you will get Q1. Scrolling down, Q1 is the first quartile, in this case 0.92. That means 25% of the numbers are below 0.92 and 75% above it. Median Q2 is 3.12. That means, and all this information you get by scrolling down. 3.12, 50% of the numbers are below 3.12, 50% above 3.12. And third quartile is 4.89. That means 75% of the numbers are below 4.89, 25% above it. And this is the picture. Okay. And they show you how to do it. Basically, you scroll down to get, first you will get the minimum, then Q1, then median, then Q3, and then the maximum. Okay. Will not use Excel. Percentiles of our data. So percentiles divide the data set into hundreds. For a number p between 1 and 99, the pth percentile separates the lowest p% of the data from the highest 100 minus p. Arrange the data in increasing order. Let n be the number of values in the data set. For the pth percentile, compute p by 100 multiplied by 100. So if you want to do 60th percentile, it will be 60 by divided by 100, which is 0.6, multiplied by the sample size. And if then L is a whole number, pth percentile is the average of the number in position L and number in position L plus 1. If L is not the whole number, round it up to the next higher whole number. The pth percentile number in the position corresponding to the rounded up value. So they want to find the 60th percentile, 0.6 times 45, 27. Since 27 is the whole number, the 60th percentile is the average of 27 and 28th position. Okay. What does it mean? That means 60% of the numbers fall below 6.45, 3.645, and 40% above it. Okay. Computing the percentile from a given data. Sometimes we are given a value from a data set and we wish to compute the percentile corresponding to the value. Following the procedure for this, arrange the data in increasing order. Let X be the number of values whose percentile needs to be computed. Use the following formula to compute the percentile. So we calculate the number of values less than X, add 0.5 to it, divide by the total number of values in the data set, and multiply it by 100. Round the nearest whole number. This is the percentile corresponding to the value X. So here they want to find the percentile corresponding to 1.9. 17 values below 1.9. So 17 plus 0.5 is 17.5 divided by total number of data set is 45. 17.5 divided by 45 multiplied by 100 is 38.9. Round it to the next higher value is 39. Okay, so that means 1.9 correspond to the 39th percentile. For the years 1882 to 2019, the 90th percentile of the annual snowfall in Denver was 80.3 inches, approximately worst percent. Less than 80.3 is 90th percentile, okay, 90%. Okay. In a recent year, 65th percentile of the data daily mean values of temperature in city of Macon, Georgia was 78th percentile. For approximately what percentage of the Denver was the temperature greater than? So 65th percentile means 78, at position 78, 65% below it, 35% above it. Recent year, 17% of the players on the National Football League weighed less than 200 pounds. Or approximately what percentile is a player who weighs 200 pounds? Okay, it's 17th percentile. Okay. Find the first quartile, find the third quartile, score 73. Okay. So we will try to enter the, let me see if I can enter the data in L1. Okay. So we will enter the data in L1. Second, plus 4, clear all list, done, stat 1. So in L1, we are going to enter the data set 58, then 59, then 62, then 64, then 67, then 68, then 69, then 71, then 73, then 74, then 74, then 75, then 76, then 76, then 76 again, 77, 78, 78, 78, 82, 82, 84, 86, and then 87, 87, 88, 91, and 97. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 28 data points. Your cursor should be sitting on 29th position where there is nothing. Okay. Find the first quartile. So stat, then highlight calc on the top row, then number 1 where stats. List is L1, frequency list. Mine is showing L2. I have to clear it by hitting the clear button in the third row and I calculate. So my first quartile is 70. Okay. Third quartile Q3 is 83. Okay. Then it tells in what position is 73. How many numbers below 73? 1, 2, 3, 4, 5, 6, 7, 8. So 8 numbers below 73. Okay. So 8 numbers below 73. So 8.5, 8 plus 0.5 is 8. 0.8 numbers below 73, add 0.5 to it, 8.5. Then you divide by total number of data sets is 28 and multiply it by 100. Okay. And it is 30.35. So it is 30th percentile. You can do the rest. Compute the 5 number. We have already calculated the 5 number summary from stat calc 1. What is the 5 number? Minimum, first quartile, median, third quartile, and maximum. Okay. So 5 number summary is given like this. Minimum, first quartile, second quartile or median, third quartile, and maximum. An outlier is a value that is considerably larger or considerably smaller than most values in the data set. Some outliers result from errors. For example, a misplaced decimal point may cause a number to be much larger or smaller than other values in a data set. Some outliers are correct values and simply reflect the fact that population contains some extreme values. Here you look at all the numbers, they're in 80 and 90s, but there is suddenly one number, 8.45. The decimal must have been placed wrong there. Okay. Outliers following present the population of 5 largest cities in the United States. Which reading is an outlier? I'll say New York. New York is much larger, is an outlier. Okay, we can calculate an interquartile range, which is Q3 minus Q1. Basically, it tells you the range of the middle 50% of the data. We can find outlier by multiplying the IQR by 1.5 and then subtracting that from Q1. This is the lower outlier boundary, and the upper outlier boundary is Q3 plus 1.5 times IQR. Okay, so they do the calculation for this number of students absent in a middle school. Their IQR is Q3 minus Q1 is 59 minus 45 is 14. Multiplied by 1.5 gives you 21. So the lower outlier boundary is Q1. 45 minus 21 is 24. And the upper outlier boundary is 59 plus 21 is 80. Then we look for numbers which are smaller than 24. It looks like there's no number smaller than 24. Is there any number greater than 80? Yes, 100. So 100 is an outlier. And we can do these calculations. I will not do it now. Okay, box plot. Okay, let's work with the box plot with this data set. So let's enter this data in L1. So second plus on top of enter, number 4. Clear all list, done. Then stat 1. Enter the data in L1, this data set. 65, 67, 71, 57, then 51, then 49, then 44, then 41, then 59, then 49, then 42, then 56, then 45, then 77, then 44, then 42, then 45, then 46, then 100, then 59, then 53, then 51. Okay. 22 data points, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, 22 data points. Then we want to do a box plot on this. So first I will press second button and y equal to. Or before even doing that, let's just press y equal to. Where is y equal to? It's in the top left. Okay, y equal to. Press y equal to. Make sure there is nothing on the side, on the right hand side of equal to sign. y1 equal to, y2 equal to. This all should be empty. If it is not empty, hit clear. Okay, once you have made sure that there is nothing on the right of equal to sign, then you hit second button, top left corner, and then y equal to key on top of it. Then you press number 1. Make sure on the first line the cursor is flashing on. Okay. Then you go by down cursor key to the second row, which is type, and go to the fourth type of chart, 1, 2, 3, 4, and put the cursor there and hit enter. This is a modified box plot. This will show you if there is any outlier. Okay. So hit enter. Okay, no, not enter. Then you press the zoom button. Where is zoom? It is the third key. So make sure your type is the fourth, flashing on it. Then you hit the zoom button, third key on the top row, zoom, and then select number 9. You will see a box plot with a number at the extreme right with a box. This is your number 100, which is an outlier. What is a box plot? At the left boundary is minimum. Then inside the box, the left boundary is Q1. Inside the box, Q2 is the second vertical line. And the boundary on the right for the box is Q3. So Q1, Q2, Q3. And then the line extends to a point on the right, which is below 100. So the number below 100 in this case, I believe is 77. It extends up to 77 because it has identified 100 as an outlier. So therefore, the right horizontal line does not extend up to 100 because 100 is an outlier. It ends at 77, which is the number just below 100. So you have found an outlier on the right by that square. Okay. So again, the box plot, minimum, then Q1, Q2, Q3, boundaries of the box, and then it extends on the right up to the maximum number if it is not an outlier. If there is an outlier, then to the number just below it. Okay, box plot is a graph, 5 number summary, along with some additional information. There are several different kinds of box plot. The one we describe is sometimes called a modified box plot. Okay. So it has identified 100 as the outlier. Technology we don't want. So again, if the median is closer to the first quartile than to the third quartile, the upper whisker is longer than the lower whisker, the data are skewed. So median is the vertical line inside the box. It's closer to Q1. That means there are large number of, and there is a lot of large number in this data set. The data set is skewed to the right, okay, because the median is closer to Q1 or the left boundary. Okay, here the median is third quartile. Median is close to the third quartile. So median is closer to the right boundary of the box. Then we are skewed to the left. Okay. So again, if the median is closer to Q1, then we are skewed to the right. If the median is closer to Q3, our right boundary, then you are skewed to the left. If the median is halfway through, then it's approximately symmetric. Okay. I will stop here today. If you have any question, you can always shoot me an email. I'll get back to you as soon as possible. And I'll come back next time with week 3 lecture. Take care. Have a nice day. See you next time.